Hello, ladies and gentlemen. I am Elang from Department of Electrical Engineering, Faculty of Engineering, Universitas Indonesia. At this moment, I would like to present our research paper that the title is The Effect of CuSCN Concentration Variations in Activated Carbon Electrode on the Perovskite Solar Cell's Performance. Generally, there are four sections in this presentation. The first one is introduction, the second one is experimental method, the third one is results and discussion, and the last one is the conclusion. We move to the first section, which is introduction. The first point is energy consumption. As we know, the world's primary energy consumption has increased by time. So we use solar energy, which is a typical candidate as an alternative energy source to avoid the increase of the carbon emission on the Earth's atmosphere. The third point is perovskite solar cell, which is the fourth generation of the photovoltaic technology, which has high efficiency and low fabrication cost. Besides the development of the perovskite solar cells, there are still challenges such as long-term stability, environmental friendliness, and mass production. So we try to replace the electrode material from metal-based into carbon-based in order to solve the metal degradation issue. And the last point is combining HTM and electrode. It will improve the quality of the interfacial contact between the perovskite and the electrode layer. We move to the second section, which is experimental method. As we can see at the left side of the screen, there is device architecture. The first one is the structure. It adopts the inverted planar PIN engineering. And the second one is electron transport layer. We use titanium dioxide, which has excellent transparency and good light absorption characteristics. And the third one is perovskite. Due to iodine-based perovskite has a favorable band gap, which is 1.55 electron volt, we use this perovskite as an active material. And the last one is electrode. We use activated carbon, which is an alternative material to the gold, and it acts as a back electrode. As we can see at the right side of the screen, there is energy level arrangement. Generally, all of the energy level value adopts from the previous studies. This energy level arrangement explains how this device works. The first one, when the photon energy is larger than the bandgap energy, a pair of electron and hole will be generated in the perovskite layer. After that, electron flow from the perovskite to the titanium dioxide and it moves to the FTO. Besides, hole created from excitation process will flow from the perovskite to the carbon and move to the FTO. The next one is preparation. Before we fabricate our devices, we have to prepare three materials first. The first one is titanium dioxide, which consists of 0.3 milliliter titanium isoproposite, 5 milliliter of HCl, and 5 milliliter of ethanol. The second one is perovskite. The perovskite solution was made of several materials, including 240 milligrams perovskite, 140 milligram lead chloride, and 1 milliliter of DMF. And the last one is carbon paste. In this paper, the variation of CuSCN concentration in activated carbon was carried out with the percentage of 0.5%, 1%, and 2%. Basically, the activated carbon powder and the paraffin oil were fixed at 0.3 gram and 1 milliliter respectively. The next one is device fabrication. In this device fabrication, there are four steps. The first one is pre-cleaning, which is conducted with sonication of FTO glass with a size of 2 times 2 centimeters square into a distilled water, acetone, and ethanol for 5 minutes for each solution. The second one is titanium dioxide deposition. The titanium dioxide precursor were deposited to the clean FTO glass, then followed by spin coating process with a rotating speed of 2000 RPM for 30 seconds. Then it was followed by annealing process with cap 425 degrees Celsius with a duration of 30 minutes. The next one is perovskite deposition, which is conducted with spin coating process at the speed of 1000 RPM for 30 seconds, then followed by annealing process at 130 degrees Celsius for 15 minutes. And the last one is the carbon deposition, which is conducted by Doppler bleeding method which is commonly used to deposit carbon materials, followed by annealing process at 300 degrees Celsius for 20 minutes and cooling to the room temperature. We move to the third section, which is results and discussion. As we can see at the left side of the screen, there is our fabricated solar cell devices. This paper compared perovskite solar cell performance with different concentration of CuSCN in activated carbon electrodes. Basically, we have three samples in this research, which are CuSCN05, CuSCN1, and CuSCN2. The measurement of the perovskite solar cell performance was carried out under sun illumination with an irradiance of about 600 watt per meter square. At the right side of the screen, there is solar cell performance table. And in this table, we can see the different performance of each sample. And CuSCN 1 weight% yielded the highest short circuit current. This happened because when the CuSCN content in the carbon electrode was less than 1%, it couldn't work properly. In addition, when the CuSCN content in the carbon electrode was added in the excessive amount, it will reduce the conductivity of the carbon-based electrode. These results are similar to the study that had been reported by He et al. It claimed that appropriately combining carbon electrode with HTM additive will increase the short circuit current. We move to the IV curve. As we can see at the right side of the screen, there is IV curve. This IV curve was obtained from Semiconductor Parameter Analyzer HP4145P. Based on the open circuit voltage, as we can see from the IV curve, open circuit voltage of the CuSCN05, 1, and 2 were 0.2 volt, 0.14 volt, and 0.02 volt respectively. The decrease in the open circuit voltage value indicates a higher recombination phenomenon inside the perovskite solar cells when the CuSCN is added. Based on the fill factor, samples with CuSCN 0.5, 1, and 2 weight% produce fill factor of 0.31, 0.32, and 0.36 respectively. Perovskite solar cell with CuSCN 0.5 weight% and carbon electrode yielded the lowest fill factor. It happens because there was poor interfacial contact between the active and electrode layer, affecting the charge carrier movement properties. Based on the efficiency value, the CuSCN05, 1, and 2 produce efficiency values of 0.0026%, 0.0035%, and 0.0002%. CuSCN1 shows the highest efficiency because when the content of CuSCN is added to 2 weight%, not only the open circuit voltage, but also the short circuit current experience a decrease, indicating the conductivity of the copper-based material is lower than that of pure carbon. After we have discussed the data and the analysis, we can pick 2 points in the conclusions. First one, to conclude, adding a CuSCN with 1% concentration in activated carbon electrode served the best performance. The second one, the CuSCN1 produced an efficiency of 0.0035%, short circuit current of 0.11 microampere, open circuit voltage of 0.14 volt, and fill factor of 0.32. That's all about our research paper. Thank you very much.